So today we're going to solve an M118 simple finite problem using combinations and permutations. Here's the problem. There are 7 Democrats and 5 Republicans on a committee. A subcommittee consists of 3 members. How many possible subcommittees could you form that include both Democrats and Republicans? So when tutoring in this scenario, the first general principle that we always want to get at is, does order matter? So we'd ask the person we're tutoring if order is relevant in this situation. Hopefully they would discern here that order is not relevant because we're forming subcommittees. There's no president, there's no vice president. The order in which we arrange those subcommittees is not important. So because of that, we're going to use combinations, not permutations. After that, the biggest thing we need to distinguish here is that we're forming a hybrid committee. We're having both Democrats and Republicans. Anytime we're forming a committee that is some sort of hybrid or any subset that includes elements from 2 larger sets, 2 larger disjoint sets, we're going to have to use the partition principle. And what the partition principle means is that we're going to have to take the total number of ways, the total number of subcommittees that we can form, the total number of subsets we can form, and then subtract out the total number of subsets we could form with just Democrats, the total number of subsets we could form with just Republicans. So to put that in simpler terms, we're going to have to find the total number of subcommittees we could form with all 12 individuals, and then we're going to have to subtract the total number of subcommittees that are just Democrat, and then the total number of subcommittees that are just Republican. And then we'll arrive at the total number of subcommittees that are both. So how would we do that? We have 12 general members, so the total number of subcommittees we could form with 3 people per committee is 12, choose 3. We already established we're using combinations, not permutations. We're then going to subtract the total number of ways that are just Democrat, or 7, choose 3. We have 7 Democrats, 3 people per subcommittee. We're going to choose 3 of those 7. From that 12, choose 3, we're also going to subtract 5, choose 3. 5 Republicans, 3 people per subcommittee. We're choosing 3 people from those 5, choose 3. From here, it's just a simple arithmetic measure, which most students typically understand at this point. But to break it down, how we would break down doing combinations on a piece of paper, and it's difficult to show without actually having a piece of paper to write on. But what we'd say is when we have 12, choose 3, or 12C3, you take the number on the left to the left of the C, and you're going to write down 3 numbers because it's 12C3. So we're going to count down 3 numbers. So 12, 11, 10. We're going to multiply those 3 numbers. We're then going to divide 12 times 11 times 10 by 3 counted down to 1. 3 times 2 times 1. So for instance, if we had 7, choose 5, we would write 7 times 6 times 5 times 4 times 3 over 5 times 3 times 2 times 1. 7 counted down 5 numbers, 5 counted down to 1. We would then do 7, choose 3 using the same exercise, and 5, choose 3 using the same exercise. That gives us 220 minus 35 minus 10, or 220 minus 45, which is just 175. So that would be an effective way, and that was a little fast, but an effective way. We'd have to see how the tutoree responds to all those questions, but to try to get them to get at the answer, we're really asking them if order matters. From there, we're asking them to sort of apply this partition principle, try to explain the partition principle, and then try to get them to do the arithmetic involved with the combinations before walking them through the steps how to actually do that. We're always trying to see if the tutoree can do what they can do before we give them the answer. We're more of a guide rather than actually a teacher. We're not going to teach them the answer. We're going to sort of watch them, and then when they need help, we're going to step in and teach them how to do it. But we really want them to always be solving problems when they can. So that's a simple M118 problem, and I hope that was clear. If it's not, just let me know.